Hello friends, welcome to Basic Electrical YouTube channel. So in today's lecture, I am going to explain the constructional details of an alternator. Okay, alternator or synchronous generator or AC generator, all are same only. See in module 4, we have two types of construction topics. One is on induction motor, construction of three-phase induction motor. Either we can predict that question, otherwise construction of alternator. Out of these two, either induction motor or alternator, definitely one question we can predict for university examination. Okay, so we can start this topic. So it is class number 8. In previous lecture, I explained about working principle of an alternator. So after that, this is the next topic. So whatever we learned, the construction of three-phase induction motor, same constructional method is followed even for alternator also. Okay, 100% matching is stator construction. Whatever you have learned, stator construction of induction motor, same thing you can write for stator construction of alternator. Okay, so before moving into the stator part, we can list out what are the major parts in alternator. Okay, so there are, in construction details, there are two parts. Okay, one is called stator. Okay, stator, and other one is called rotor. Okay, so these are the two major parts in an alternator. See, coming to stator, and in alternator there will be two windings. In alternator there will be two windings. One is called field winding. One we can call it as field winding. Other one is called armature winding. Other one is armature winding. One is field winding and another one is armature winding. See, let me write like this. Okay, stator will be like a circumferential distance. So almost all electrical machines will be in this type of construction, in a rotating structure. In a circumferential distance. So this you can consider as a stator. So now rotor I will write inside. Okay. So this rotor will always mounted on the shaft. This center circle is called shaft. Okay. So we can place, see this part is stator. The outer circle is stator and inner circle is rotor. Okay. We have recommendations. We can put these windings either in stator or in rotor. See, suppose if I put field winding in the rotor, if I put the field winding in the rotor, let it be, we can write the winding will be like this. Okay, if I put field winding in the rotor, then it is called rotating field. See, rotor will rotate. Okay, stator will not rotate. It will be in a stationary position. Okay, but we can place the windings either in stator or in rotor. Okay, got it? See, you should say, if I put field winding in the rotor, then we should call it as rotor is rotating. Okay, what is rotating? It is carrying field winding. Then we can call it as rotating field. Okay, if I put field winding in the rotor, then it becomes rotating field. Got it? Similarly, now if I put armature winding in the rotor, then what we should call rotating armature. Okay, got it? If I put armature winding here in the rotor, then you should call it as rotating armature. Okay, if I put field winding in the rotor, then call it as rotating field. That is one part. Other way, if I put field winding in the stator, so stator also have field windings. Winding will be there. Okay, stator winding now. If I put field winding in the rotor, in the stator, then what we should call stationary field. Okay. Now if I put armature winding in the stator, then what you should call stationary armature. Okay, got it? So now what I am doing, I am putting field winding in the rotor, armature winding in the stator. Then what type of construction it is? stationary armature rotating field. Okay, stationary armature rotating field. Look at here, stationary armature and rotating field. This is one type of construction. So next is, now I am going to interchange. Now put field winding in the stator. Okay, armature winding in the rotor. Then what we should call it as? Rotating armature. Okay, rotating armature and stationary field. Rotating armature and stationary field. Okay, so these are the two possible manufacturers will going to design the alternator. Okay, see this type of arrangement, stationary armature and rotating field. This type of alternator are used in generating station. Okay, it going to develop very high voltage. Okay, to generate higher voltages, we are going to use this type of arrangement. Stationary armature and rotating field. Nothing. Two windings will be there, armature and field winding. If I put the armature winding in the stator, it becomes stationary armature. If I put field winding in the rotor, it becomes rotating field. Okay, this arrangement used for generate higher voltages. Got it? Next, rotating armature and stationary field. Now I am putting armature winding in the rotor, it becomes rotating armature. Okay, if I put field winding in the stator, it becomes stationary field. This type of construction is recommended for low voltage alternator design. Okay, so to design a 440 volt alternator, 3-phase alternator. Okay, and 3-phase alternator with this voltages up to 400 volts. Okay, but this type of arrangement used to generate 11 kilovolts, 33 kilovolts, 6.6 kilovolt, 3.3 kilovolt, like that. For higher voltage, this type of construction is recommended, and for lower voltage design, we need to go for this type of construction. Okay, sorry. Understood, guys? Okay, sorry for some throat disturbance. Okay, guys. Understood, guys, about the concept of stator and rotor. Okay, what type of arrangement we have. Okay, we can look into this later in the upcoming lecture. There is a lot of advantages why they are going for this and this. Okay. Okay, guys. I think you have noted down the concept of rotating field and rotating armature. That will be quite useful. Okay. So now let me start first stator construction. Okay, how the stator will looks, how it is designed. Okay, see, for simplicity I wrote 2 circles. Okay, so here I am going to make a slot. Look at here how I am going to make it. Okay, draw a line like this. Okay, and do like this. Okay, like this you must write. Okay, like this you complete this entire circle. Okay, so what I am writing, this is nothing but stator slot. Okay, stator slots. So like this you can write it. Okay, as neat as possible. See, after writing this, then there is a red part here. You erase this one. Then it looks like a slot. Okay, got it, guys? So like this you finish this entire circle. Okay, friends. So after writing like this for this entire circumferential distance, it looks like this. Okay, so this is called stator construction. See, it is like a silicon steel plate. Okay, it is made up of CRGO material. The stator is made up of CRGO material, means cold rolled grain oriented sheet steel. Okay, or silicon steel. So this material will have high permeability and low hysteresis losses. That is the feature of this material, CRGO material. High permeability and low hysteresis loss. Less hysteresis loss. Got it? So that you can, what I explained, that you can make your own notes while watching the video. Okay guys, so this is a plate, a laminated plate. The thickness of this plate, the plate is designed with this structure. The thickness of this plate varies from 0.3 mm to 0.5 mm. That is the thickness of this plate. So like this, so this is one plate. They are going to join several number of plates, laminated plates, side by side and stamped together. Then you will get a certain length of the stator core. See, in exam you must write only this much. Okay. So in this part, what we written? No, this part. Okay, this one. This one is called stator slot. Okay, stator slot. Okay, and this curvature part is there. No, this one. This one is stator tooth. Stator tooth. T-O-O-T-H. Tooth or teeth. Both are same. See here in stator tooth, this function is provide mechanical balance. Okay, or magnetic balance. Got it? So what is the function of the stator slot? See, the function of stator slot is we can house the conductors. We can place the winding. Stator winding, we can place it inside this. Here open is there, na? There you can put the winding material. Okay, copper. Winding material is generally copper or aluminum. But we are using copper only because copper is highly malleable and ductile. We can bend the copper according to our requirement. It won't lose its tensile strength. Okay. However, if I go for aluminium, so its tensile strength is very less. Okay, if the windings will take several turns, bendings and all. So aluminium is not recommended. Okay. So for higher voltage ratings and all, only copper is recommended. See, now this one is what I written, no, this red part. So this we can call it as stator winding. This we can call it as stator winding. Only this much you have to write in exam. Okay. Explain construction details of alternator means the construction divided into two parts. One is called stator and another one is rotor. Rotor we can discuss later. Write heading stator. Write this diagram. That's it. Then what to write means you should write stator core is made up of cold rolled grain oriented sheet steel or silicon steel. Okay. This material, this CRGO material will have high permeability and low hysteresis loss. So this is a laminated plate or laminated sheet. Okay, the thickness of this lamination varies from 0.3 mm to 0.5 mm. Lesser the thickness of lamination will going to reduce eddy current losses. Okay, why this variation in thickness means that will going to reduce eddy current loss in a machine. Okay, got it? So lesser the thickness, losses will be less. Okay, so okay, fine. See now till here you must write. Now additional point is how the stator core is made, how the stator core is designed. That is important. See now I am going to write a little bit understanding picture. Okay, please cooperate with me. Please have some patience. Okay. Okay guys. So this is how it looks. This is first plate. Next plate I put behind this. Okay. Another plate behind like this. Finally, I am stamping all the laminations together. Okay. Then it forms a certain length of the stator core. This length we can also call it as axial length. Okay, got it? So further also we can write remaining diagram we can write like this. So it looks like this. Okay. So we are going to place winding conductors here. So see, this is quite complicated diagram. Okay, it is written only for understanding purpose. So this part will be here. Okay, got it. So this is how it looks. This is a stator core. Complete, it is called stator core. How much length is required, that and all comes under design calculations. It depends on rating of the machine also. Okay. Alternators are rated in kVA, kilovolt ampere. Okay. Based on the rating, the size of the machine also increases. Okay, got it, guys? So this much you have to write, but don't write this extended lines and all. Okay, it is only for understanding purpose I wrote. Okay, so pause the video, copy down the entire this part. This is about stator construction. What to write I already explained. Okay, please go back the video and play it and write it down the notes. Okay, next we can discuss rotor construction. Pause the video, we can discuss rotor. Okay friends, now we can see the rotor construction. Okay, see the rotor construction divided into two types. Okay, one is called sailent, sailent, sailent type alternator. Okay, and another one is non-salient pole type alternator. Okay, non-salient type alternator. Okay, see the rotor construction. Okay, we are placing field winding in the rotor. Based on rotating field construction, we have two types of alternator. One is called salient type, another one is non-salient type. So we are placing the field winding in the rotor, hence we have two types of alternators. Okay, got it? However, for both salient type alternator and non-salient pole type alternator, the stator construction remains same. Okay, only rotor construction is different. Okay, so this is a rotor. Outside this rotor, stator will be there. For this rotor and that rotor, stator construction remains same. So now let me draw salient pole type alternator. See, this center circle is called shaft. Okay, rotor, this is called rotor. Rotor mounted on this shaft. Okay, and this shaft is coupled to mechanical input. Okay, turbine. Whenever water falls on turbine, turbine going to rotate. If turbine rotates, turbine shaft coupled to this rotor shaft, so this rotor also rotate. Okay, got it? So what do you mean by alternator? Generator, AC generator. What is the input for generator? Mechanical. What is the output? Electrical. Okay, got it? So that's why it is also called generator, AC generator. So let me write a detailed salient pole type rotor, how it looks. See, first you write one small circle, after that you write outer circle. Okay, like this. Okay, you write neatly. So my writing will be look like approximate good. You try to write better than me. Okay, you write neat circle. See, now I am going to write one more circle close to this outer circle. You maintain, there is a gap between outer circle and this circle. Maintain almost 1 to 3 mm gap. Okay, this gap should visible only for you. Like that you write. Okay, so now I am going to place a poles. I am going to fix poles. Okay, on this rotor. Okay, look at here. So this is a pole. So ink is not there. Okay, enough. Like this you write. Like this you write 4 sides. So other side you write like this. So what are these? Poles. So very easy to write now, but you should write with patience and neatly. So good diagrams will get marks, even though if it is looking wrong, in depth looking wrong. If overall looks good means the evaluator will give marks. You need not to worry. Okay. So try to write the diagrams as neat as possible in exam. You should impress the evaluator with your diagram. Okay, write like this. So don't write like this. Okay, one with bigger pole and another one with smaller. One more is very much bigger. So don't write like this. Write almost equal distance. Okay. So these are poles. Let me take this is north pole, south, north, and poles. See, these poles are called projected poles. Okay. And these poles are fitted. These poles are fitted. These poles are fitted to this outer body of this rotor. Okay. These poles are fitted with nuts and bolts. Okay, got it? So it is, these poles are fitted to this outer part of the rotor. So like this. So what I am writing now, this is called bolt. Okay. So I am fixing this poles to this rotor. So like that you write all the sides. Okay. See, however, it looks like this. This is inner circle and this will be outer circle. So I am writing a pole like this, and here I am making like this. Okay, like this I am making. So that indicates it is properly fixed. Okay. If it is not visible, you can concentrate on this. You can look this one. See, now you must write a mechanical support for this. So this what I am writing now, it is called mechanical support. Draw two lines parallel to each other. Okay, like this you write. Mechanical support. See, this is entire called rotor. See, this outer part, this is called flywheel. Okay, this we can call it as flywheel. It runs with, flywheel is nothing but it runs with its own moment of inertia. Okay, so smooth movement will be there. Okay, so now that poles are fitted to this outer part of the flywheel, and this lines nothing but mechanical support. It provides mechanical support, and these poles we can call it as projected poles. Projected poles. But I want to place windings, no, field windings. So field windings you can place it here. Okay, on side of the poles. You write like this, three chota circles, small circles you write like this. Okay, on all the sides. So it is, the diagram is going to look good. Okay, write maximum 3 only. If you return 2, that is also good. Don't write 10 year, time killing. Okay, so after that you draw one like this. Okay, slant line in that circle. Okay, so what does this mean? This is called field winding. Okay, see, this circles are nothing but field winding. See, this field winding are wound around the poles. The poles are fitted to the rotor. If the rotor rotates, field also rotates. That's why it is called rotating field. This is one type of construction. This construction name is sailent type, and this one is non-salient. That I will go to later. Okay guys, so this is a complete diagram of sailent pole type rotor. Okay, this is alone rotor. Stator I already explained. So outside of this you can write that stator. Then it is complete sailent pole type alternator. Now it is sailent type rotor. Okay, got it? Okay guys, and this center one we not named it. So that one you can name it as what? Yes, very good, shaft. Okay, got it. So this is how the sailent pole type rotor looks. Now we can go to non-sailent pole type rotor. Draw one small circle. After that you write two circles. After some gap you write one more circle. So writing this diagram quite complicated. Please observe carefully. Now I am going to write it. So first you write the mechanical balance. Okay, mechanical balance. So what is the center circle? That center circle is called what? Very good, shaft. So this diagram is not according to scale. So please kindly cooperate. See now you must write like this. Okay, you should write like this. So what I am writing now, this is called main pole. Okay, you don't like that, you write all the four sides. So let me write the quadrant diagram like this for better understanding. So now this side also you write like that. Okay, like that you write all the four sides. So what is this? These are called poles. Okay, main poles. So these poles will have good magnetic properties. Okay. So now this I can name it as north pole, south pole, and north and then south. So after writing this, you can erase this dotted lines. So we have wrote this only for supporting purpose. Okay, later you can erase this everything. Okay, so these are called main poles. Next you must write, you have to fill this remaining part. You should not leave blank. So the remaining part we can fill in this way. Okay, like this 1, okay, 2, and like this you write 3 times you write it. Okay, after writing, okay, you erase here and you erase here. Okay, and erase here. It should look like a slots. How it is looking now? Okay, you should write in such a way like this. Okay, so like this. Okay, between this and this you should fill like this. Okay, so now I am going to write this side. So maximum I am going to write 3 slots. Okay, see now I am going to erase. Okay, this one I am erasing, this one I am erasing, this one I am erasing, and this one I am erasing. Okay, here this one. Okay, erase like this. See how it is looking. So now you write this one also. So like this you finished everything. So you can forward the video, so that I will directly can forward the video till when it comes here. So but I will write okay, so continuously you can forward it directly. What you need, what you are expecting, you can directly go to that point. Okay guys, got it? So write with patience. Okay, write as neat as possible. So next is last part. See, the comparison between these two alternators are very important. Okay friends, now this non-salient type alternator look like this. Now you erase this part, okay. You have closed down this main poles. You erase like this, okay. Erase like this. Only main poles, okay. So this is how it looks. Non-salient type alternator look like this. So let me label the parts. So these are called main poles having high magnetic properties, okay. So these are called supporting poles but acts like a slots. Magnetic properties are less. So between here, from here to here, in the open part we are placing the windings. This is called field winding. That is called field winding. Okay, got it? So now, and this and all, this part is called mechanical support. Support, and this center one is called shaft. So this one we can call it as shaft. So like that you can write remaining parts. Okay. So these are the major parts in a non-salient pole type alternator. See, what is important for exam is you have to write some points related to this diagram and some key points related to this diagram. So to write those key points, I am going to draw a stator outside of this rotor for better understanding purpose. But you need not to write. What I am going to modify this diagram. Pause the video, copy down this as it is. At last I will give some points. Then you copy down those points. So let me write a stator around this. This entire thing is called rotor. Okay. Now I am going to write a stator around this rotor. So ink is not sufficient. So that's why it's not clearly visible. So understood, this is a circle. Okay. So I'm writing another circle. So now this, what is this outer circle? It is called stator. Assume stator is having 3 windings, 3-phase supply. So this will be R phase winding, R2 and R1, and this will be Y phase winding, Y2 and Y1, and another one will be B phase winding, B2 and B1. Okay, this is about 3-phase sailent pole type alternator. Now there also I am going to write stator. Here also I am going to write the stator part. So don't write this one. I am taking this to understand how this rotor construction, where it is applicable, okay, everything. To understand those points, I am writing stator. Okay, this is rotor, outside is stator. So let me take stator will have 3 windings. So this is R phase winding, R2, R1, then Y phase winding. All these 3 windings are displaced by 120 degree with respect to each other. So next is B phase winding, B1 and B2. Now let's see how the working will happen. See, this is a rotor. Okay, rotor is mounted on the shaft, and we are giving all these field windings. These circles are there, no? These are all called field windings. All these field windings are connected in series. We are giving a DC supply to those field winding with the help of slip ring and brush assembly. By using slip ring and brush assembly, we are feeding supply to this rotating part. Okay, when our field winding carries current, produces a magnetic field. Since rotor rotates, magnetic field also rotates. Those magnetic field cut by the stationary conductors, and hence EMF will be induced in the stator. Okay, and we can collect this induced voltage in two format. Either is star connection or delta connection. To get star connection, we have to short R2, Y2 and B2. Short or finishing ends R2, Y2 and B2. This will be B1 and this will be B2. Then becomes star connected alternator. So then for delta, you can R2, Y1 you short it, Y2, B1 you short it, B2, R1 you short it. Starting it you take supply. Then it becomes delta connected alternator. Same concept here also. Rotor outside stator. Rotor is coupled to turbine shaft. Whenever water falls on the turbine, turbine rotates. Turbine rotates, the shaft coupled to this rotor shaft, rotor also rotates. But we need magnetic field now. That's why we are giving supply to this field windings. Those field windings carry the current, produces magnetic field. This magnetic field and main pole flux cut by this stationary conductors, EMF is induced. So we can easily collect the induced quantity if I keep the armature winding in the stator. So if I place field winding here, then what could be this winding? Definitely it is armature winding. What type of construction? Rotating field, stationary armature. Where it is used? High voltage generation. Okay. Reverse used for low voltage application. What is reverse? Rotating armature, stationary field. That is low voltage generation. Okay guys. Now we can discuss in detail the comparison of these two. Alternator is very much important in examination. So let me start with this first sailent type. See, look at here. The poles, all these poles are projected out of this surface. So another name for sailent pole type alternator is projected pole type alternator. It is called projected pole type alternator. Here poles are projected? No, it is not projected. So it looks like a cylindrical in structure. We cannot see, even though poles are projected, we cannot see that because it looks overall circle. So that's why you write a non-projected pole type alternator. So it is non-projected pole type alternator. Got it? So next is key point number 2. Another name. It is non-cylindrical in structure. See, the sailent type alternator, it is not in exact circle. So it is non-cylindrical in structure. Okay, because lot of gap is there. Okay, you can write here a non-cylindrical rotor. You can write it as non-cylindrical rotor. That side you can write it. It is cylindrical rotor. It is cylindrical rotor. Look at here. The rotor looks exactly circle. Okay, yes. So it is called cylindrical rotor. Okay, pause the video and copy down these 2 points. Okay, friends. Next, a few more points. Next is very important is air gap. Air gap. See, air gap is non-uniform. Air gap is non-uniform in this type of rotor. See, what is air gap, sir? See, look at here. The gap between, this is outer is stator and inner one is rotor. This is called a gap, air gap. The gap between stator and rotor is called air gap. See, we have here less air gap. This is stator, this is rotor. See, lot of air gap is here. Again, less air gap, more air gap. Less air gap, more air gap. Less air gap, more air gap. So, we can write this point. Air gap is not uniform. What about in this case? See, the gap between stator and rotor. This is gap. See, in the entire diameter, the air gap is constant. So that's why you can write confidently, air gap is uniform. Okay, uniformly distributed. The gap between stator and rotor in the entire 360 degree is same. But here, not like that. Less, more. Okay. So that is one thing. Next is, see, this type of alternator, larger in diameter and smaller axial length. AL means axial length. The word, this is the word I am telling. Axial length. In short form I wrote AL. Larger in diameter. This type of alternator looks very bigger in diameter from the front view. The diameter of this alternator is very big. But axial length is very small. What is axial length? Okay. So this is called axial length. Okay. So from the side wave, you can see the length of the alternator is very less, but overall diameter is very big. That is a speciality of this type of alternator. What about this one? Non-salient type alternator. See, this type of alternators are smaller in diameter but larger in axial length. See, larger in axial length is this one. See, look at here. Okay, this is the overall length of the alternator. This is the length of the alternator. But diameter is very less. So that is the difference. You can write smaller diameter, SD, smaller in diameter, okay, and larger axial length. Large axial length. Note down the difference. Larger in diameter, small length. Here, smaller diameter, large length. Okay, got it? Understood? Very, very important point. These 2 points. Air gap non-uniform, and that side uniform. Small, larger diameter, small length. Smaller diameter, larger length. Okay. So next, sailent pole type alternator is also called low speed alternator. Okay. This type of alternator used in low speed application. Okay. And this non-salient pole type alternator used in high speed application. Used for high speed application. Example for low speed alternator. All hydro turbines. Low speed alternators, nothing but sailent pole type. We are using this alternator in hydro power plants. So it is also called hydro turbines. Okay, for hydro turbines, we can go for sailent pole type rotor. Okay, so this you can write use for hydro power plants or hydro turbines or water turbines. Okay, but here this type of alternator we can use it for steam turbines. Okay, steam turbines. So low speed alternator, high speed alternator. Example, hydro turbines or water turbines. Example, steam turbine. All types of steam turbines. Okay, the recommended alternator is non-salient pole type alternator. Okay. So next, coming to efficiency and all. Efficiency of this alternator is less. Okay. This alternator efficiency is good. Losses are very less. Efficiency is very good in this alternator. Here, very less. And see, due to air gap, here less rate of change of flux. Here later rate of change of flux linkages is less. Okay, sorry, more. Easily can link the flux can link the conductor. But here due to lot of gap, whatever flux produced here, it takes lot of time to link with the conductor. Due to that, what happened? EMF induced, whatever the induced quantity in the stator is not exactly sinusoidal. Okay, there will be some fluctuations in the magnitude of the induced quantity. So this is one drawback of this alternator. Okay, EMF non-sinusoidal. Induced EMF is non-sinusoidal. And this side you can write, since we have air gap is uniform, we have constant rate of change of flux linking with the stationary conductors. So we can predict what we can predict? Sinusoidal induced quantity. So we can predict almost pure sinusoidal. Okay, pure sinusoidal waveform. So we can get like this. Okay, from this alternator, pure sine wave. But however, here in this alternator, we can get like this. Okay, so some disturbance will be there in the magnitude. Okay, got it? That is happening due to not proper rate of change of flux linking with the conductor. Okay, due to non-uniform air gap. However, we can get the good quality. We have to utilize this space. Put one more pole here. Okay, put one more pole here. Like that, by introducing more number of poles projected, so you have to utilize the space. So from that, we can improve the quality of the waveform. Okay, got it? But here 100% you will get good quality waveform. Okay, got it guys? Then coming to final point, construction. This type of alternator construction is very simple, but this is complicated. This construction is complicated. Okay, difficult to design. easy to design. Then finally, damper windings, we are using damper windings. Okay, very important. Okay, DAMPER. We are using damper windings only in sailent type, and we are not using damper windings. So you can write no damper windings required. No damper winding. No damper winding is required. So what is damper winding? See, if there is any mechanical vibrations, in order to suppress the mechanical vibration, we need to use damper windings. Okay, also called vibration dampers. Okay, why means, see, this rotor used in water turbines, this rotor shaft coupled to turbine shaft, if water pressure on the turbine is suddenly increases, what happens? Turbine will get slight vibrations. So since turbine start vibrating, the turbine shaft coupled to this rotor shaft of the alternator, this also going to get vibrated. So whatever the vibration effect on turbine will also occur on the alternator. So in order to reduce those vibrations, okay, we have to use damper windings. It is nothing but just like a shock absorbers in vehicles. Okay, two-wheelers, four-wheeler. Okay, you are crossing humps. Okay, your vehicle passes from this side to this side. Okay, so the passenger cannot feel that changes. Suppose if the shock absorbers not there means, then you will get a nice effect. Okay, then next time onwards you will stop your vehicle and you can easily cross it. Okay, because of shock absorbers you can cross the road with in a running condition. Okay, got it? So like that, when machine turbine vibrates, rotor shaft also vibrates. In order to avoid such vibrations, we need to use damper windings. But damper winding not required here. Here such vibrations will not occur because we can have strong control on steam flow. Okay, we have better controlling strategies to flowing steam to the turbines, steam turbines. Steam is passing through turbine, so that we have a control effectively. So therefore, however, still if the steam pressure is very high, beyond our expectation, then turbine may get fluctuate. So turbine fluctuates, rotor also fluctuates, but that thing is nullified in this type of alternator. Vibrations rarely occur. Okay, here regularly we can predict vibration. Okay, throwing a water on the turbine blades is quite different, and passing high pressure steam on the turbine blades is different. Okay, so water will have a lot vibrations on the rotor compared to steam. Okay guys, these are all the difference. You must write it in your notebook. Here and there I written some key points. If you watch the video properly without forwarding, you could have write better points. Okay guys, I think this video is very useful. So in next lecture, I am going to explain why we need to rotate field. Why can't we rotate armature winding? Why you are rotating field? There is lot of advantages. That thing I am going to discuss in next class. Okay, next video lecture, that is class number 9. So please guys, tell your friends to become member to our channel. So let them watch the video and score good marks like you in university examination. So have a nice day. Take care. Please give like to this content. Okay. So in next class we can do advantages of rotating field over rotating armature. Bye bye. Take care.